Alright, so for this example, we don't have functions. We don't have f of x. We don't have g of x. We just have some information. Somebody already did the work for us. Somebody went ahead and plugged 2 into f and plugged 2 into f prime. They actually found the derivative, and they found that f of 2 is 4 and f prime of 2 is negative 3. Then they have this different function g of x. They found the derivative. They're telling us g of 2 is 5 and g prime of 2 is equal to 6. So they did a whole bunch of work for us. We want to figure out what the derivative of h of x is here at x equals 2. So h of x is equal to 2 times f of x minus 6 times g of x. So our goal, the first thing that we need to do, is we need to figure out what the derivative of h of x is. So we have h prime of x, and we're going to take its derivative. So I have 2 times f of x. Well, 2 is just a constant multiple. So constant multiples, like 2, they just multiply the derivative of whatever function they're multiplying. So that 2 is going to stay there, and it's going to multiply the derivative of f of x, and the derivative of f of x is f prime. I don't have the function, so I don't know what it is, but I know it's f prime. Likewise, the same thing with g of x. We have a 6 there with g of x, and so that technically a negative 6, so that negative 6 is going to hang out there, and then we're going to multiply by the derivative of g of x. There's h prime. Done. Now we want to evaluate this at 2. So h prime of 2 is simply going to be 2 times the derivative of f at 2. Well, the derivative of f at 2, the derivative of f at 2 is given to us right here. That's negative 3 minus 6 times the derivative of g of x. The derivative of g of x is given to us, whoops, we will just undo that, is given to us right here, 6, and so we will utilize that. And then it's just multiply, and make sure you're multiplying correctly and adding and subtracting correctly. 2 times negative 3 is negative 6. Negative 6 times 6 is negative 36. And negative 6 minus 36 is negative 42. No problem. Now, we can do this again, even if we have a different f of x. So, getting rid of everything that we did so far, what if I change, sorry, not f of x, what if I change h of x? What if I make h of x a little more complex and not just a quick 2 times f of x minus 6 times g of x? So let's make h of x, let's do a product rule. So let's h of x equal f of x times g of x. All the rest of the information is still the same. So we're going to do the exact same thing. We're going to take the derivative of h of x. Since we have a product, we need to use the product rule. Order of the product rule really doesn't matter as long as you have the appropriate things multiplying. So the product rule says we need to do f of x times g prime of x, and then we're going to add to that g of x times f prime of x. Because it's multiplying, you can multiply in any order, so we could have f prime of x first. Because it's adding, it doesn't matter which one of these goes first. Either way, we have the derivative. Now that we have that, our goal is to find the derivative evaluated at 2. So we simply just plug in 2. We're going to find f of 2. Well, f of 2 is given to me. F of 2 is 4. And so that's a 4. Times g prime of x. Well, g prime of x is also given to us. G prime of x is 6. And so we'll utilize the 6. Plus g of x. G of x is also given to us. G of x, or g of 2, is 5. Times, now we want to do multiply f prime of 2. F prime of 2, also given to us. It's right there, negative 3. And so we're going to multiply by negative 3. And now again, we just have to make sure that we're adding and subtracting and multiplying and dividing correctly. So 6 times 4 is going to give me 24. 5 times negative 3 gives me a negative 15. 24 minus 15 is 9. There's the derivative of h of x in this case. I don't care how we write h of x. We could write it as anything that we want. We would just simply apply the rule for h of x, whether it's the product rule, the quotient rule, constant multiple rule, whatever. Take the derivative, plug in the appropriate information, and you're good to go.